Hi everybody, welcome back. Now let's get back to work with our lathe. In this second part, we are going to show you how to set up the servo as a spindle in step direction mode and demonstrate how it works. But first, we want to see how the servo works in jog mode without any connection to a PC. We've connected the B2 servo driver to 220 volts and the motor to the driver. To run the motor in jog mode, we need to set the speed in the PR8.03 parameter of the driver. Factory default speed is 100 RPM. Let's try to run it at 500 RPM. To start the jog mode, we need to activate the PR8.02 parameter. We can see the word jog on the driver display screen, and we can hear the sound of the driver's fan. In our case, we have an up arrow indicating reverse rotation of the spindle and a down arrow for forward rotation. When we are using jog mode, the servo driver does not show us the speed on the display, but we know we set it at 500 RPM, and we can use the original G0768 digital readout for the spindle speed. It shows us 495 RPM. That is almost the correct speed. Most likely, the original lathe's DRO is not 100% accurate. Okay, now let's try the reverse rotation. The DRO shows us the speed of 502 RPM. The spindle's rotation is easy and stable. Let's go back to PR8.03 and set it to the maximum speed of the motor, 3000 RPM. To activate jog mode, we use PR8.02, and let's see what will happen. Whoa, the speed is 3000 RPM. Nice! The sound is louder, but looks like everything is normal. We're not hearing any bad noises. Okay, the test in jog mode was successful. What's next? How to connect the Lichuan AC servo to the M16D board. The solution, it turns out, already exists. Arturo Duncan developed the C34LC adapter specifically for the Lichuan B2 AC servo driver. This adapter has two RJ45 connectors, one for connecting the servo motor as an axis, and the other one for receiving the servo encoder's feedback. There, you can also get the C46 adapter for the encoder. Okay, let's try to configure Mach4 to use the servo as a spindle. Arturo Duncan sent us a configuration executable file for the Mach4 lathe with clear path servos for X and Z axis, and we've already installed this configuration file. But there is nothing in it for AC servo as a spindle. So we go to the Configure tab, select Plugin, and then the PoKeys plugin. Let's highlight the string with our PoKeys board and choose Configure. We see Device Configuration, CNC4PC Motion Device. Go to the Spindle tab and enable spindle speed measurements, and Mach4 will show us the real speed of the spindle servo. According to information from Lichuan, our motor's encoder has 2500 ticks per revolution. Let's put that in here. And enable threading support. In the Encoders tab, everything that we need is already enabled because the configuration executable file was created for a similar encoder. Let's go to Configure Control and select the Axis Mapping tab. Let's enable and map OB1 as motor 5. Then choose the Motors tab. Select motor 5, which we've already mapped. For counts per unit, we put 4000. For velocity, 1800. And acceleration, 20. You can try to play around with it yourself and you may find more optimal settings, but keep in mind that you will need to change electronic gear ratio in the B2 servo drive settings. Next, we go to the Spindle tab. Put max RPM 3000 on the first line, 3000 for max spindle motor RPM, choose step direction spindle axis OB1, and enable rigid tapping. About the Mach4 application. Everything is quite comfortable and understandable. Great graphics, nice interface, But there are little tricks from Artsoft which aren't mentioned anywhere. One specifically being, do not rename the computer on which your Mach4 is activated. Activation will disappear. And when we tried to return the old name to the computer, it did not help. The PC ID has been changed forever. So we had to reactivate it. For one purchase of Mach4, Artsoft gives you 12 activations. So we've already lost one of them pretty stupidly. Anyway, let's get back to the lathe. We installed C34LC and C46 adapters, and we are ready now to test how Mach4 manages the spindle. We set the speed in Mach4 jog mode at 3000 RPM and started the spindle. But the speed is only 620 RPM, and the speed is not stable. It's jumping around from 580 to 640. Let's decrease the speed to 1500 RPM. Now we're reading 310 RPM, and the speed continues to be unstable, approximately from 280 to 330. We stopped the spindle, but Mach4 is still in enable status. Uh-oh, we've got wobbling. This is strange because in the jog mode of the B2 servo drive, everything works well. Looks like something must be wrong with inertia and the electronic gear ratio. Let's go to the B2 servo drive user manual and try to figure out what's going on. We found the parameter PR5.18 load inertia ratio is set to 0.01 by factory default. By trial and error, we've determined the value of inertia, and we set the value 4 in PR5.18. Now it is necessary to determine the value of the electronic gear ratio so that the given RPM coincides with the real RPM. We set the value 25 in PR1.02 and the value 6 in PR1.04. Let's see what we got. We set the spindle speed at 1000 RPM and start the spindle in jog in Mach4. And we get exactly 1000 RPM. Now 2000 RPM. Same thing, spindle speed coincides with our given speed. When we try to stop the spindle, there is no wobbling at all. Let's try to get 20 RPM. With the original G0768 motor at 100 RPM, it was easy to stop the spindle with your hands. With a Mach4 servo motor, the spindle is impossible to stop with your hands, even at a speed of 20 RPM. It's very good to use low speed, especially if we need to cut short threads. Now trying a speed of 100 RPM. Excellent! We could not even imagine how cool it is to have full control over each single step of a spindle motor. The Mach4 motor has passed the test perfectly. Many thanks to Arturo Duncan for excellent products as well as great help and assistance. Originally, we converted our Lathe Grizzly G0768 into CNC for using with Mach4 software and a parallel port. But the number of modern computers with a printer port is getting smaller. There are practically none at all. We have to look for old computers and install 32-bit Windows XP on them, an operating system that is already 17 years old. But we'd like to have a new computer, possibly even a laptop, with a modern 64-bit operating system so that you can continue to run Fusion 360, which requires 64-bit OS, and finish your project without leaving the workshop. We started thinking about Mach4 software and some kind of motion controller that would work via USB or Ethernet. Arturo Duncan advised us of his new development of the M16D motherboard for Pokeys 57E, and we altered the controller of the lathe. Many thanks to Arturo for his advice and for the configuration executable file for the M16D and Mach4 lathe. The customer support at CNC4PC is fantastic. We highly recommend everyone to take this first step into the future and update your software and motion controller. Good luck! Coming up, we have 2 projects lined up. Remodeling of a 4-axis 6040Z router with the replacement of steppers with Lichuan hybrid servo motors and the replacement of the motion controller, and conversion of the regular medium-size milling machine PM727M into CNC with the installation of clear path servo motors and the assembly of a new motion controller. Tell us in the comments which project you want to see first. Thanks for watching. See you next time!